Hi, this week we're focusing on the seventh grades, particularly in expressions and equations. This week we're going to use algebra tiles and some number lines to help us solve equations and inequalities. So let's get started. These are the list of pieces within the cluster for the equations and expressions. So in our introduction to algebra tiles, for each pair of expressions, state whether they are always, sometimes equal, or never equal. Explain how you know. X can be any rational number that we can think of. So 1x and x and so forth. So to get to my algebra tiles, the ones that I'm going to particularly use within our class here, I'm going to click manipulatives, move this over for you. And I'm going to click on the second one, the algebra tiles and base 10 pieces. So it comes up in this screen. I really like these particular algebra tiles by clicking here, and then we have our list. So we have the x values, and we're not going to quite get to the x squareds yet, but we also have a y tile, an x times a y, and then the unit tile. Note that if I double click an item, it can rotate for us further. If we click one time, we get a negative value. So our first one is just x and 1x. By having 1 out here, that implies that there is a 1 in front of x, even though we don't see the numbers. So x and 1x are always the same. Then I have x plus x plus x plus x. I'm just going to move these closer together here. All right, so x plus x plus x plus x. So I've got 4 x's, which is always the same as 4x. Okay. Then we have 3x plus 2. 3x plus 2. Is that the same as 3x? Never. These are never the same. And 3x and x3. Well, that would be part of the commutative property since we can multiply in any direction. So x times 3 or 3x is always the same. And then I have 3x, so 1, 2, 3x and 6. 1, 2, 3, 4, 5, 6. This is sometimes true because when I put in 2 for the x value, I could get 6. If I put 2, 4, 6, these would be the same. But if I did 1 in the x value, 3 times 1 would be 1, 2, 3, so that would not be the same. So this last one is the only one that is sometimes true. All right, let's go back to our lesson here. Line it up for us. Okay. Equivalent expressions will always have the same value regardless of the types of numbers or variables included. We can determine if expressions are equivalent by substituting numerical values for the variables. We can use properties of operations to transform one expression into the other. Choose the expression or expressions that is or are equivalent to the expression 3 times the quantity x minus 6 using algebra tiles. Our original equation or expression is 3 times the quantity of x minus 6. So we need 3 of x minus 6's. So this would be considered x plus 6. So I'm just going to turn all of these negative so that they become x minus 6. And I need 3 copies of this. So we're using that same area idea that we've used since elementary school to help build these for us, except now we're using variables and not just numbers. So along this left side, we can see there's 1, 2, 3, and along the top I have x minus 6. So is that the same as 3x? Here's 3x. Is that the same as 3x minus 6? There's 1, 2, 3 negatives. All right, 6 negatives. So although they both have the 3x's, our individual numbers are short, so A is not appropriate. Is this the same as x minus 6 times 3? Well, absolutely, it's the same. We want 3 copies of x minus 6, except it's just in a different order. So we could easily rewrite this by flipping these around, and maybe instead we'll line them up this way. But we're still going to get the same result if I were to add more of them down here. So B is good. Is this the same as 3x minus 18? Well, if I were to count all my pieces, here's 1, 2, 3x, 3, 6, 9, 12, 15, negative 18. C is correct. Is this the same as x minus 6 plus x minus 6 plus x minus 6? Well, here's x minus 6 plus x minus 6 plus x minus 6. So the only true answers are B, C, and D. A is the only one that did not work for us. If we multiply x over 2 plus 3 copies of 1/4 by 4, we get 2x plus 3. Is 2x plus 3 an equivalent equation if we go backwards to x over 2 plus 3 copies of 1/4? Let's see if they are by plugging in the numbers. We know that if we plug in a number, it should work for any number that's chosen. So let's choose 1. When I plug in 1 for x, we get 2 times 1 plus 3. And 2 plus 3 is 5. So let's then plug in 1 for the x value with the fractional one. So we'd have 1/2 plus 3/4. We know that is the same as 2/4 plus 3/4, so 5/4 altogether. Notice they're not the same, so they are not equivalent. All right, write an expression for the sequence of operations. Add 3 to x. Then subtract that result from 1. So whatever that result is, we want to take 1 minus whatever that is. Then we're going to double what we have. Add 3 to x. So far we're starting off at the same. Double what we have. Then subtract 1 from this result. So although they sound the same, they are not the same. So be careful with wording. Be careful where things go. In these expressions, x can be any rational number. Find pairs of expressions that are equivalent and show how you know. I know that you know how to use the distributive property, and I'm going to show you some things that may or may not be comfortable for you. So be patient as we go through these. It's not a traditional way that we have seen or you may have seen in the past, but it is a way that 7th graders are reasoning, and so it's important that we know how to reason with them and show them how to reason differently than just straight algorithms. So I'm going to start with the top two. Let's see if I can make these be the same. So I start with 3 5/10 minus 4x. Well, we know that we can rewrite it as an addition problem. So 3 5/10 plus a negative 4x. Then I can use our properties, our associative properties, and rewrite this as negative 4x plus 3 5/10. So those two are equivalent. And we can check by plugging in a number. So let's say I plug in 5 for x, so 3 5/10 minus 4 times 5 is 3 5/10 minus 20, which is negative 16 5/10. Similarly, negative 4 times 5 plus 3 5/10 gives us negative 20 plus 3 5/10, so negative 16 5/10. So they are equivalent. Let's try 6x and 2x minus 1 plus x plus 3. So I'm going to take 6x and I'm going to rewrite it as 2 plus 4 times x, because I know 2 plus 4 is 6. Okay, and then I'm going to separate them using the distributive property, giving me 2x plus 4x. And then I'm going to add 1 and subtract 1 here. I'm going to add 1 and subtract 1 because plus 1 and minus 1 is the same as 0. So we're adding in a 0, which does not change our overall expression. Then I'm simply going to rewrite them. So 2x minus 1, 4x plus 1, so that I can start to develop what that second equation might look like. So then what I did is I took 2x minus 1 and grouped them together. And then what I did, so I grouped these two together, and then I rewrote 4x into an x and 3x, because x plus 3x is 4x. And I rewrote 1 using 3 minus 2. So now I get this part to match this piece up here. However, we have these leftovers of 3x minus 2. So those two are not going to work. Let's try 6x and 5 halves x plus 7 halves. So 6x we know is the same as 12 over 2x. So manipulation a little bit. I can rewrite 12 halves as 5 1/2 plus 7 1/2 x, which means then that I can separate them using the distributive property. So 5 halves x plus 7 halves x. So those two are the same. And we can check using our numbers if you're uncomfortable. So if let's say 1, so 6 times 1 is 6, and if I did 1 for each one here, I'd end up with 5 halves plus 7 halves, which is 12 halves, or the same as 6, so they're equivalent. Let's try 1/3 times 8x. Is that the same as 8/3 x? So 1/3 times 8x, I can rewrite this using the commutative property. So 1/3 times 8, which is the same as 8/3 x. So these are equivalent. Let's try 2 times 2x plus 1 to equal 2 plus 4x. So using our properties, if I have 2 copies of 2x plus 1, that's the same as 2x plus 1 plus 2x plus 1. If I rearrange them and combine them together, that gives me 4x plus 2, or 2 plus 4x if I rewrote it. Let's see if I can't get those to match somehow. So let's start off with 4x plus 3 minus x plus 1. So I'll distribute the negative piece, giving me negative x, negative 1. I can rewrite them combining my x's and my digits together. So 4 minus x plus 3 minus 1 gives me 3x plus 2. Let's do the similar technique to the 2x minus 1 plus x plus 3. Rearranging them, we get 2x plus x minus 1 plus 3, so 3x plus 2. So these two are equivalent together.